All right, so let's go ahead and take a look at MPF. What is that about? MPF is basically your inspection. Stands for Modular Policy Framework, which is the implementation of what is known as deep packet inspection. No, not like IPS. IPS checks it against a signature database. IPS checks it against a well-known attack. This is basically checking for different protocol characteristics, and if you want to block something based on a certain characteristic of the protocol, it does allow you some level of filtering capabilities. IPS is well-known attacks, again, which is a signature check. But what is this deep packet inspection? To understand that, first thing that you need to understand is how different protocols work. Let's take a look at simple example of FTP. I have an FTP client, wants to communicate to an FTP server. Okay, what protocol does FTP client use to communicate to an FTP server as a standard? What standard protocol or port number does it use? TCP/21. And what does it use TCP/21 for? Enabling or setting up the session. So when the initial connection is made, it's made to port 21. What's the source port? Random, right? High order port number. Agreed? Now, what is 20 used for then? If this is your connection, let's say this is 21999 as an example. Just like any TCP connection, Arjun, whenever a packet or a connection is made to on a TCP based connection, the source port is randomly selected by the application, and that it is 1024 to 65,535. Now, once this connection is established, this is only for your control communication or commands. This is not for data flow. The data flow happens on port 20 by default. But the characteristic of that second connection is that it is not made from the client to the server, it's made from the server to the client. What happens over here is once the connection is established from the FTP client, the user logs in, specifies your username, password, gets authenticated. At that time, the client tells the server, hey, listen, I know you need to make a data connection to me. Please make it on port number, let's say 25111. But who's telling who to make that connection? Is the client telling the server, I'm going to open up a connection for you. Please make a connection on that port number. The server responds back and says, okay, I'll make a connection, the data connection on what? On that 25111 from a source port of 20. This is where the data will be transmitted. So let's say I want to upload a file from the client to the server. I will use the put command. Let's say put file1.txt. I'm going to use that put command where? On the client. Put means upload, right? The actual upload will take place here. So although I'm showing you a green arrow, that's just who initiates a connection. Once a connection is established from port 20 to this random client port that was defined, 25111, this connection is used for what? Uploading or downloading. Everybody understand that? Now this is normal FTP. The problem with this is that if you have a firewall in the middle, let's say the client was on the inside. So this is your inside network. This is your outside network. The server is somewhere on the internet. The client makes a connection. Will the first connection be allowed? By default. From 21999 to 21. Yes, it's going from what? High to low. And it'll create the return entry allowing 21 from that IP. Let's say this IP is A and this was B, allowing 21 from A to come back into 21999, which is to B. So the return entry is allowed. So this connection, no problems. But who's establishing the second connection? And is that return connection? Is this going to be allowed? This is not return connection, right? It's a brand new connection from, again, established from A, which is this guy, IPA, with a source port of 20 to B to a source port of 25111. All right. So to fix these protocol issues, they needed to do what is known as deep packet inspection, in which the firewall is aware of the way FTP works. So it knows that this issue will arise. So when the initial connection is made from where to where? From the client to the server, and it's trusted. The firewall starts inspecting the traffic at layer 7 and looking for what? What is it doing by inspecting or looking at layer 7 for FTP? It looks for the port number. It knows this is a trusted connection. It knows that the server needs to make a connection from what? 20. It needs to figure out what the client will tell the server what random port to allow. And because it's inspecting or looking at what? The FTP connection, it will dynamically create an entry from 20A to 25111B. Is it maintaining predict sessions? Means what? No, it's actually inspecting the actual connection that is being made. It's looking at what? Layer 7. It's inspecting. It is inspecting layer 7. It's actually inspecting the layer 7 characteristic. It actually checks and sees what the client is telling the server in terms of what port number to use. And based on that, it'll create the entry for that. So it's not predicting it, it's actually looking at it. Understood? No, it's they're not, but that's what the inspection, when you inspect FTP, you're telling the firewall to check the port number. The operating system is aware of this intricacy of FTP, so it checks the FTP connection for that port number so it can create the return entry. Think about it being like the same thing that we did to allow 21 coming back to 999, that was just based on the default or implicit inspection of what? Of TCP. Remember the stateful inspection? Think about it being an extension of it. Now I'm not just doing it based on the normal source port, destination port. I'm actually going into layer 7 and looking at the characteristic and creating the return entry. Understood? But the thing about this is called deep packet inspection, DPI. The thing about this is every protocol at layer 7 will work differently. I just showed you that it's inspecting what? FTP, and it does this. This default inspection is on by default. So I don't need to worry about this for FTP. Why? You take a look at your configuration over here. I'm going to go to my ASA. Show run. I want you guys to check this class called the inspection default. What does it tell you over here? There's a class called inspection default, which is a default name. And if you check over there, it's matching or classifying some traffic. So even I didn't do this. This was done by default. This is on your default ASA config. Show run, or show run I did. I want you guys to see if I do class inspection default, what is this match question mark default inspection traffic? That's what it's matching. It is checking or classifying all this traffic. It in the default, it also inspects ICMP traffic, not inspects, sorry, classifies ICMP traffic. So this is on by default. I didn't do that. It was there in this class map called what? Inspection default. This inspection default is a class map that is called inside this policy map, which is also there by default, called the global underscore policy. The global underscore policy is calling what? This class called inspection default, which matches all those ports that I showed you, including what? FTP, ICMP, HTTP. It checks it. Says, oh, classifies it and takes action on it. What action is it taking? It's taking an action on FTP. It's taking an action on SQL. It's taking an action on SMTP, TFTP, but it does not take any action on ICMP. That's why ICMP doesn't work. Although it's classified, there's no action taken on it. But at the same time, do you notice there's FTP there? What does this inspect FTP do if I've already told you that TCP and UDP traffic is inspected by default? The reason they have this over here is to fix that irregularity with FTP. It checks for what? It checks for that port number. I don't need to tell it what to do. The operating system knows what to do. When you say inspect FTP, it knows to check for what? Check for port in a trusted 21 connection, which is an FTP connection. So yes, by default, FTP would work, not because of the TCP inspection. It would work because there is an inspect FTP there by default. You get my point. And what does the operating system tell FTP to do? It tells FTP to check for what? Check for port number. I don't tell it that. It knows to check, to do that. Everybody okay with this? I'm just making you aware, what does that inspect FTP do over there? It's doing it automatically, but I also want you guys to be aware that for every one of these protocols, it is different. My objective was not to go in and check each and every of these protocols. My objective over here was to tell you that every application in terms of layer 7 is different. So every one of these over here is doing a specific characteristic, which is fixing some problem or the other, or providing security for some. Let's take another example so you guys see how different they are. ESMTP, there's an inspect by default done for what? ESMTP as well. What is that doing? What is this ESMTP doing over here? The ESMTP protocol, or let's take SMTP as a protocol in general. In that protocol, there's about 60 commands that ESMTP can use. DPI is checking for it, but it's not taking any action yet by default. No ICMP inspection by default. You can add it, but it's not doing it by default. I'll do that as well. Let's understand ESMTP first. So there's about 60 commands with ESMTP. About 15 to 20 commands are required. The other ones are more informational commands. What operating system are you running? How much space do you have on it? So these 60 commands are actually sometimes detrimental to you from a security perspective, because they can give up information about what? About your device that SMTP is running on. So what they've done over here with inspect ESMTP, they have specified the required commands. Who has done that? Cisco's done that. So let's say you had an SMTP server on the inside. So this is your firewall, and let's say this is your DMZ, and you have an email server over here. Would you allow access to this email server? How would you do that? This is coming from the internet. Some SMTP server on the internet wants to communicate to your mail server. You would NAT it and then create an ACL saying what? Permit TCP what? Any to 192.168.3.25 EQ 25. Agreed? That would allow somebody on the internet to establish a connection to the server and send and receive mail. Once they establish an SMTP connection over here, by default there's 60 commands that they can use, but some of those commands can compromise the server. So when you have this inspect SMTP on it and the packet comes in, it checks, oh, the ACL is allowing it, but then what it does, it automatically checks for the required commands which are inside the operating system, which are allowing SMTP communication, but it's not giving access to all the commands. It's only giving commands that are required to send and receive mail. You get my point? So all the unrequired commands that can give up information, although SMTP is allowed to that particular server, those commands that are being sent, which are SMTP commands, might cause issues with the security of the device, so ASA will automatically block it. So over here, what with ESMTP, what is inspection of ESMTP doing? Again, checking at layer 7, but for SMTP is checking for what? Required commands. If it's a command that's not required for sending and receiving email, it's going to block that command, although your ACL allows it. Again, deep packet inspection, fixing something in terms of security for a particular protocol. Does that make sense, guys? And I don't want you guys to go through the list and find out what each one is doing, but understand the inspections that you have over here are there for a reason, to fix a certain irregularity with that particular protocol. Good. And because I'm going into layer 7, it is called deep packet inspection. There are custom check fix for different protocols. Correct. Each one is different because every protocol at layer 7 works differently. Now you do have the ability, if you want to do something, again limited by what the operating system allows you the capability of doing. For example, there's an inspect for HTTP, which is not on by default over here, in which if you wanted to, you could do blocking of URLs. So you could check the URL field inside HTTP at layer 7 and block it. So you can also create your own customs, but nowadays nobody does that because you have actual devices like the WSA, which we'll take a look at later on in the course, or the FTD that does that for you guys. Nobody does that manually because these devices give you the capability of doing it based on categories. So you can say block all the news websites. Here, if I'm blocking URLs, I need to tell it which URLs to block one at a time. There's no categories defined with this inspection. I'm just telling you that it is capable of checking URLs. Nowadays, nobody does it, but the capability is there. Understood? So I want to show you a couple of things over here. I'm not going to do anything over with these guys because my main objective over here was to show you that's on by default. I didn't need to do anything special about it. But the things that I want to do over here, I want to do two things over here for DPI. So this part is done. Deep packet inspection using modular policy framework, MPF. It allows the firewall the ability to check layer 7 characteristics there are a bunch of protocols that are checked by default and a specific action taken. The checks and actions are dependent on the protocol. For example, DPI for FTP would check the port that the server, one second guys, will use to communicate to the client. DPI for SMTP, I should put it in the same. DPI for SMTP will check for allowed SMTP commands for transferring, for transmitting. Good so far? All right. By default, there is, before that, DPI is implemented on the ASA firewall by using a 3-step configuration called the Modular Policy Framework, MPF. In MPF, a protocol is classified in a class map. An action is specified for the classified traffic in a policy map. The policy map is applied to the firewall. The default class map is called, you guys remember? Inspection underscore default. Oh man, my arm is aching. The default class map is called inspection default. It checks for a bunch of default protocols. The default class map is called in a default policy map where the action is taken. And what is that called? Default policy map is called global underscore policy. The global underscore policy is applied globally, which affects all traffic. All right, so the global policy is applied globally, which affects all traffic. Now,